Okay, this lesson is on the probability of multiple disjoint and non-disjoint events. What do you think disjoint means?
I have no clue.
It's not right.
It's separate. They're not together. Disjoint is separate. Where if it is non-disjoint, that means that they are together or somehow overlapping. Okay, now we talked a little bit about or in our last lesson, and this time we're going to talk about two different things. So you have the probability of A and B happening. Whenever you see and, you are going to multiply. And when you see or, you are going to add. Okay? So and you're going to multiply or you are adding. Okay. So let's start with example 1. A bag contains 6 white, 3 blue, and 7 green marbles. If 2 marbles are chosen, okay, this time we're choosing 2. If 2 marbles are chosen at random, what is the probability of each event? Okay, so 2 are chosen. So since they didn't tell us that we choose one and put it back, that means that it's chosen and it stays out because you're going to end up with the 2. Okay, so what is the probability both are white? So you're choosing one and then you're choosing another. Okay, so how many white are there?
6.
And what's our total again?
16.
Okay, so total is 16. So both are white. You have a choice of 6 out of 16. And this is one where we're going to multiply. But we've taken one white out.
So 5 out of 15?
5 out of 15. Because there's one less white and there's one less total marble. Okay? So you have to pay attention to both of those numbers. And then you're going to end up multiplying these together. But it's always easiest to reduce first if you can. So I look at 5 and 15, right, Tu Cheng, and I can see that I can reduce it. So 5 divided by 5 is 1, and 5 goes into 15. Do you see anything else that can reduce? Okay, so 2 goes into 6 3 times, and then 2 goes into 16 8 times. Anything else? Try again. 3 and 3. So 3 divided by 3 is 1. 3 divided by 3 is 1. Okay? So then, and again, circle what's left. Remember, tops you multiply at tops, bottoms at bottoms. So 1 times 1 is 1. And on the bottom, 8 times 1 is 8. So that the probability that both will be white is 1/8. Okay. B, probability both are green. So what's our probability for green? 7 out of 16. We draw 1 green marble. So now how many greens do I have left?
6 out of 15.
6 out of 15. Very good. And then do we notice anything that can reduce?
3.
Because, so you have your bag of all your marbles. I drew a green one out. So I drew it and I'm setting it down. So now there aren't 7 green ones in anymore because one of them is out of the bag. So I only have 6 green in there. And then there used to be 16 marbles in the bag, but I took one out. So there's one less than 16, which is 15 out of your total. Does that make sense? Okay. So now I can divide by 3, right, to 6 and 15? So 6 divided by 3 is 2. 15 divided by 3 is 5. And then 2 and 16 can reduce, right? So 2 divided by 2 is 1, and 2 goes into 16 8 times. Nothing else counts. So on the top, 7 times 1 is 7, and 8 times 5 is 40. And that is your answer. Okay, questions?
I hate these cards.
Okay, example 2. Now notice on this one, do you see that word or? Okay, so pay attention when you see or, it's pretty specific. Okay, so probability of getting a jack. So what's the probability of getting a jack? 4 out of 52 plus or, because or we're adding, or a 6 of clubs. How many 6 of clubs are there? 1 out of 52. Now this is where you have to kind of pay attention, and that is, and we're going to talk about this more later, but you want to make sure that these events do not overlap. So like if I said, what is the probability of getting a club or a 6 of clubs? See how they would overlap, and you'd have to end up subtracting out the overlapping part. But to just kind of have that in the back of your head. So we add those together and we get 5 over 52, and can that reduce?
No.
No. Okay, try B on your own if you haven't already. I'm just going to give you about 15 seconds.
No, just because they didn't satisfy. It's gonna be so 4 will be very close.
Okay, so what's the probability of getting a diamond? Good. 13 out of 52. Or means plus. And how many clubs are there? 13 out of 52. Do any of those overlap? No. So you have 26 out of 52, which reduces to 1/2. Good. Okay, moving on. Unless we have a question. All right, example 3. Sonia is moving and all of her CDs are mixed up in a box. 12 CDs are rock, 8 CDs are jazz, and 5 are classical. If she reaches in the box and selects 3 at random, so she's choosing 3 at random, find the probability of each. So did we see or in this at all? No. So since we didn't see or, it's an and you're multiplying them together. Okay? So the probability of all jazz. Well, first of all, how many total CDs do we have?
25.
Okay, so total equals 25. So right now she's drawing out 1 CD. So what is the probability it's going to be jazz? Okay, 8 out of 25. Okay, times. And so she took out 1 jazz. And so what's the probability of the next one being jazz?
7.
Very good. And then the next one will be 6 out of 23. Are we all okay with how that just happened?
Yeah.
I'm going to say it one more time just in case some of you are confused and you're not telling me. So we have a box. We're pretending. Here's my box. Okay? Tons of CDs. 25 to be exact. I reach in here. I take 1 CD out. How many are in the box now? 24. And we're just saying that what's the chance this is jazz? So we know there's 8 jazz. So there's a chance that 8 out of 25 this is jazz. I take it out, it's gone. Now there's 24 in here. I draw another one out. We're pretending like this is jazz. We don't really know. But it's 7 now out of 24. So now that I've taken that one out, now I only have 23 in here. Does that make sense?
Yeah.
Okay. All right. So now we want to reduce as much as you can so you don't end up with this huge number at the end. So when I look at this, I know that 6 and 24 can reduce, right? So 6 divided by 6 is 1, and 6 goes into 24 4 times. Okay, now what do you notice can reduce? Good. So 4 divided by 4 is 1, and 4 goes into 8 2 times. Is there anything else there?
No.
No. So tops to tops, bottoms to bottoms. So 2 times 1 is 2, and then all in the bottom I have is 25 and 23, and that equals,
What happened to 7? 7.
just kidding, and 7. That's why you should always circle all your numbers. So 14 on top, and then 25, 1, and 23, and that makes
A big number that we don't know.
575. So it's 14 out of 575. Yes?
Why can't we go to 6?
Because you're only, remember how like when we were doing,
They asked for 3 CDs.
there's 3 CDs, so it's like we have our 3 blanks. So the first one you had 8 out of 25, you took 1, yeah? Is that good? All right, so probability of all rock. I'm going to give you guys about 30 seconds to try this one. Try to just set it up. So you don't necessarily have to multiply it all out, just how are you going to set up those 3? And you maybe want to make 3 blanks that you're multiplying together, but know that these are going to be fractions. So much whining. What's the answer?
I got the answer. But is that reduced? Yeah, it is.
Yeah, it is.
No, you don't reduce it.
You always want it reduced in simplest form. Okay, so what's my first fraction going to be?
12 out of 25.
Very good. 12 out of 25 are rock. Good. 11 out of 24 and 10 out of 23. So now we can reduce. Okay? It doesn't matter how you reduce. You might do it differently than me, but I'm going to go with 12. 12 divided by 12 is 1, and 12 goes into 24 2 times. Then I say, okay, 2 can cancel with 10, and that becomes a 5. And then 5 goes into 25 5 times. And I don't see anything else. So on the top, I have a 1, an 11, and a 1, which makes 11. On the bottom, I have a 5, a 1, and a 23, which multiplies to be, bless you, 115. And that is in your simplest form. Questions?
No.
Okay, moving on. Okay, now this is what I talked to you about. 2 events are overlapping if they have one or more outcomes in common. So when you're doing this, is you have to take the probability of A plus the probability of B and subtract out where A and B overlap. Okay? This will make sense as we go through. Okay? We already kind of talked about this, but complementary events are opposites. So an example of complementary events would be like rain versus no rain. They're opposites. Male versus female, true, false, win, loss, even, odd, so on and so forth. Okay? The probability of an event happening and the probability of it not happening, both of those add together and make 1. Okay? Okay. Here we go. Example 4. A card is drawn from an ordinary deck of cards. Find these probabilities. Okay, so what's the probability of it being a queen?
4.
Okay, now notice this is and. So it's going to multiply. The only time you have to worry about the overlapping part is when you have ors. Okay? So, queens, 4 out of 52 and a heart. 13 out of 52, and then we want to reduce.
Why did I put 25? Wait, so you don't worry about the overlapping unless it's 4?
Exactly.
Equals to 1.
Because you're adding and subtracting. This is just checking if this will happen. But yeah,
Queen and a heart do together.
they do. You're right. But you only have to worry about it, like I said, with the or, when you're adding and subtracting. Okay? So, 4 goes into 52 how many times? 13. And 13 goes into 52 4 times, right? So you multiply, we end up getting 1 over, and 13 times 4 is 52. So 1 out of 52 chance. Okay, a queen or a heart. Okay, so how many queens are there? 4. 4 out of 52. Plus, how many hearts are there? 13 out of 52. How many overlap? How many? 1 is correct. Do we understand that? Because there's 1 queen of hearts. So you know how there's 4 queens? And then there's, you know. Yeah, so you added the queen with the queens, and you also added the queen with the hearts. And there aren't 2 of those, so you have to subtract 1 out.
This is kind of difficult for someone who doesn't play cards.
Yes, that's why I'm talking to you about it. And you know what, in a few minutes, I'm going to write out all the cards on the table, and you'll see, on the board, and we'll kind of look at it, okay? So this, we end up adding 13 plus 4 is 17 minus 1 is 16 out of 52, and can that reduce?
4 over 13.
You can divide by, okay, if you divide by 4, we end up with 4 over 13. You could have also like divided by 2 and then divided by 2 again. Okay, queen or jack, how many queens are there? 4 out of 52. How many jacks are there? 4 out of 52. Do any queens and jacks overlap?
No.
Nope. So we add those together and we get 8 out of 52. We can divide by 4 to the top and the bottom, and we end up with 2 over 13 is correct. Okay, a 10 or a 9. How many 10s are there? 4 out of 52. How many 9s are there? 4 out of 52. Do 10s or 9s overlap? No, so we get 8 over 52, which we know reduces to 2 over 13. Okay, a 5 and, pay attention, there's an and. So we don't have to worry about overlapping. How many 5s are there?
4.
4 out of 52 times, how many black cards?
26.
Good. 26 out of 52, or you can write 1/2. I'm sorry. I'm trying to up.